In this tutorial we'll be talking about vectors. If I'm driving a car 60 miles per hour, that's called a scalar. I have a number, 60, and I have a unit, miles per hour. Together those tell me how fast I'm going. If I also add a direction, say north, then that's a vector. In physics and mechanics especially, we'll use these all the time to identify the direction things are happening and by how much. So let's say I have a ball here and it's falling. My velocity vector would be downwards, and let's say it's moving at 3 meters per second and it's in the downward direction. So together that represents a vector. We represent that vector with an arrow showing the direction. The longer the arrow, the higher the value of the number, and the shorter the arrow, the smaller. So let's say we want to add vectors. This is a very important feature. Let's say I have a vector A that's like this, and I'll denote a vector with like that, and I have a vector B that's like that. What we'll do is, if I want to come up with an operation called A plus B and create a new vector, then I'll take A, I'll lay it out, and I'll take the B vector and I'll draw it from the end of A downwards. And the resulting vector is C. So graphical addition is an easy way to get an idea what's going on. We lay the vectors tip to tail, and the resultant is this from the start of the first to the end of the last. Here we're going to learn about the components of a vector. Here's a vector A that is in the up and to the right direction. It's on an XY plane, and the direction is shown here by the angle relative to the positive x-axis. So what we want to do when we take the components is to identify, well, how long is this vector in the x direction, and I'll call that A sub x, and how long is it in the y direction, I'll call that A sub y. I can redraw AY over here. Hasn't changed the vector, it's still pointing upwards and it has the same length. Why do I do this? So that we see a very familiar looking right triangle. We'll use all the math and trig that you know about the right triangle in figuring out what's going on. Now in this situation, the sine of my angle, sine theta, is equal to the opposite over the hypotenuse. The opposite is AY, and the hypotenuse is A. Those are both vectors. They have little arrows over them. And what we're going to do is we're going to just use these vertical bars to signify that's a magnitude. That's a magnitude. So how long is the length? If I want to know then what AY is, I can just algebraically solve AY, the length of it, equals A sine theta. So that tells me how long is this vector in that direction. Likewise, I can do the same thing. The cosine of theta equals AX over A. So AX equals A cos theta. So I can break a vector down into its two components, and the behavior of if an object is right here and being acted on by a force or an acceleration or something like that, these two vectors in the perpendicular directions together act just like this one vector, the original vector. So these two components are functionally equivalent to the original vector. So let's break this vector down into its components. A has a length of 25 meters per second, and the direction is 60 degrees above the x-axis. We know that AY equals A sine theta, and that equals 25 meters per second times the sine of 60 degrees. When you calculate this, make sure your calculator's in degrees, not radians or gradients. And when you calculate this out, A in the y direction is equal to 21.65 meters per second. Likewise, A in the x direction, that component, equals 25 meters per second cosine 60 degrees. And when you break that, that's 12.5 meters per second. What if I have the components? How do I combine these into a vector? Here are two components, AX and AY. I'm going to move AY over to the end of AX. And what we see is that A is now a vector like that. What does Pythagoras tell us about this? Pythagoras says that A, the length of A, equals the square root of AX squared plus AY squared. So the total length of this hypotenuse is just applying the Pythagorean theorem. Now, assuming we don't know what A is yet, can I find this angle theta here to identify the direction of the vector? The answer is of course. We use trigonometry. The tangent is equal to the opposite over the adjacent, SOHCAHTOA, and that equals AY over AX. So I can combine any vector components together to find the magnitude of the resulting vector as well as the angle. So let's try this out. I have two vector components. In the x direction it's 12.5 long, and in the y direction it's 21.65 long. I'll move the y vector over so that I can draw my right triangle. So that's my vector A. So the length of A is equal to 12.5 squared plus 21.65 squared square rooted. And if you calculate that out, you get 25. Let's assume this is a velocity vector, so this would actually have units of meters per second then. In order to find the angle, I want to take the inverse tangent of 21.65 over 12.5, and that results in an angle of 60 degrees. So how would I add two vectors together to get a resultant vector? Well, the answer is we'll find the components, we'll add the components that are in the like directions, and then the resulting vector would be combined from that. So we have here a vector A. It has a component in the x direction and a component in the y direction. We also have vector B with a component in the x direction and a component in the y direction. What I'm going to do is I'm going to add the vectors, and graphically they would look like this. Let's call that C. So I want to find out if C equals A plus B. I want to find out how to figure that out quantitatively. Well, we're going to add the components. So CX, the x component of C, would equal to AX plus BX. CY would equal AY plus BY. Once I have the components, then I can get the magnitude with Pythagoras and the angle with the arctangent. So in order to add vectors graphically, I take the vectors and I point them end to end, and the resultant is the sum. In order to add vectors in a quantified manner, I'm going to take their components, AX plus BX, add them together to get a component CX. I'm going to take AY and BY, add them together to get CY. Okay. So let's practice adding two vectors with components. I have a vector A that has a length of 12, a vector B that has a length of 15. I need to find AX and BX. I need to find AX and AY, BX and BY, add them together to get CX and CY. So, AX equals A cos theta, and when you calculate that out, you get 10.4. AY equals A sine theta, and you multiply that out, you get 6. BX equals A cos theta. In this case, theta is 60 degrees, and you get 7.5. And BY equals A sine theta, and when you calculate that out, you get 13. So, I can add these components together, so CX is equal to 10.4 plus 17.5, 7.5 to give us 17.9. CY is equal to 6 plus 13 equals 19. Now I can find the length of C. That's equal to Pythagoras, 17.9 squared plus 19 squared, square root. When you do that, you get an answer of 26, and theta equals tangent inverse of 19 over 17.9, and that gives you an angle of 46.7 degrees. So how does that look on our graph? C would go from the beginning of A to the end of B. It would have a length of 26, and it would have an angle of 46.7 degrees.